Another type of isomer is what we call geometric isomers. In these isomers, atoms are connected in the same order, but groups are on different sides of a double bond. We go back to our example of the isomers of butene, C4H8. One isomer is 1-butene, where the double bond starts at carbon number 1. But for 2-butene, there is more than one way to draw it. We can draw it where, if you just focus on the carbons, they are in a zigzag pattern. Or we can draw it where the carbons are more in a U. These are actually different compounds. While they are both 2-butene, if we draw a rectangle around the top molecule, we notice that the two CH3 groups are all the way across at opposite corners of the rectangle. We call this isomer the trans isomer. Much as a transatlantic flight goes all the way across the Atlantic Ocean, a trans isomer has similar groups all the way across the double bond. If we draw the rectangle on the other isomer, we find the CH3 groups adjacent to one another, on the same side of the double bond. This isomer is called the cis isomer. Cis literally means on this side of, or for us, on the same side of the double bond. Now, that doesn't mean on the same carbon. In fact, if the two CH3 groups were on the same carbon, it would be yet another isomer of C4H8, called 2-methylpropene. For now, we want to be able to identify cis and trans isomers. But why doesn't the CH3 group on one of the carbons of the cis or trans isomer simply flip up or down, making the two isomers the same? The answer to that has to do with what is called free rotation, and we look at that in the next section.